Today, as a bonus, we have a talk by a world-famous scientist who's been involved in many exciting discoveries of human ancestors and our relatives, Dr. Bruce Latimer, who is the former director of the Cleveland Museum of Natural History. Dr. Latimer.
Okay, now I've been instructed not to cross my arms because it makes funny sounds. What is that? Is that an EKG? Yeah. That's right. Yeah, this is still hot, right? Okay, well, I'll stay away from that. All right, well, thank you for coming. Thanks so much. And as you see here, happy birthday. It's bicentenary of Charles Darwin's birth and the 150th of the publication of Origins of Species. Now, what I'm going to talk about, and it won't be long, but I'll be talking about how he has influenced studies in human evolution. And that's very important, but I'm going to go a step further than that. I'm going to say that the Origins of Species and the concept of evolution via natural selection is the most profound and powerful idea that any single individual has ever had. It has altered the way we view our universe. It's altered the way we view ecology. There wouldn't even be ecology. The concept of global climate change, meaningless without evolution. The concept of medicine is now being influenced. The concept of human anatomy and human physiology and even human behavior is being completely rethought. That's how powerful this idea is. It's amazing. And it's elegantly powerful because it's not that difficult a concept. It's a beautiful concept. And when we apply it to human evolution, which we're doing, we now can say things, and I wish he were here. You know, I invited him, but he has a full calendar. Darwin couldn't be here. But it's too bad because when he would find out about Lucy and he found out about Artie, he wouldn't be surprised in the least. That's a wonderful thing. So that's what I'm going to talk about. And as I go into this, I'm going to start with this. And I don't start with a Darwin quote, I start with a Dobzhansky quote, who was one of the great evolutionary biologists of the 50s and 60s and 70s, a brilliant man. And he said, nothing in biology makes sense except in the light of evolution. And that is absolutely true. Nothing. There are people now looking on other planets for life. What a fantastic thing. And do you know what they're doing? They're applying evolutionary theory. Do I think that evolution works on other planets if there is life? I guarantee you it does. How can I say that? Because I'll tell you that if you're living in a world that has limited resources, and I can't imagine a world that doesn't have limited resources, if you're living in there, there's competition. There are winners and there are losers. And if you have variability within a population, which we can't imagine one that wouldn't have because of mutations, and if you've got heritability, pass these things on, which we can't imagine you wouldn't have, the winners and losers, the winners are going to pass on those characters that gave them an advantage. That's natural selection. Is it working out in the universe? If there's life out there, yes. Do I think there's life out there? That's a different lecture. I think it's probably, if you've got liquid water, then in that case you've got limited temperature ranges, and if you've got it long enough, yes, I think you'll have life. My guess is there's blue-green algae all over the place. Do I think there's intelligent life like us? No, I don't. But that's another lecture. We could talk about that later. Because to get to humans to where we are today, boy, I got to tell you, that's one rough and rugged road, and I can't imagine it would ever happen again. So here he is, and here's the book. Man is descended from a hairy-tailed or quadruped, probably arboreal in its habits. Now, I like the fact that he chose the adjective hairy. He's kind of a hairy guy himself. But he recognized that humans were not created in one moment 6,000 years ago. We must, however, acknowledge, as it seems to me, that man, with all his noble qualities, still bears in his bodily frame the indelible stamp of his lowly origin. How did he come up with that idea? No one else had come up with it before. He came up with it because he had no fossils. He used comparative anatomy. Light will be thrown on the origin of man and his history. That's the end of this edition, the first edition. And you know, by the 6th edition, he got really crazy. He got really gutsy and he put much light. But in the first, he was a little worried about it, and he just said light will be thrown. And those drawings are from T.H. Huxley's book. And the point is, they used their primary and their most powerful argument was comparative anatomy. Of course, he did get in trouble. A lot of people didn't want to hear that because he had knocked us off of our pedestal. Homo sapiens was no longer something that's special. We're still special. We're weird animals, there's no question about it. But we weren't that different. We were still mammals. Now, I throw this up as an example. There are certain questions that you can ask utilizing the paradigm of Darwin's that you couldn't even imagine to ask before. And that's the beauty of a hypothesis or a theory, is it gives you a new way to ask questions. And boy, does he do that. This happens to be the back of a human. Now, I've chosen this, and I'll show you why in a second. The big muscle, does anyone have a laser pointer? The big muscle on your back, in fact, if you go like this, you'll feel it. That's trapezius. And that's the big muscle you see up there. It attaches to the back of your skull and runs down to your spine. It allows you to shrug your shoulders, that sort of thing. Oh, thank you. That muscle. Now, for those of you who have had human anatomy and those that are going to take human anatomy, you're going to find something very strange. All the muscles on the back, they all get innervation, nerves that come out of the spine. It's where they should come out of. That makes sense. Not trapezius. Trapezius gets the cranial nerve. Anyone want to take a stab at what nerve it is? No, it's accessory nerve, 11th cranial. So it comes down to that. Now, why on earth would a back muscle get a cranial nerve? Doesn't make any sense. Well, it does make sense. When you look at this guy, now anybody from the museum knows who this guy is. That's Dunkleosteus. At the Cleveland Museum of Natural History, they have the largest collection of these guys in the world. A giant fish, a huge predator during the Devonian, roughly 350 million years ago. Now, this guy's now extinct. It's great big, they have great big plates on their heads, big shearing teeth, but it had a unique style of catching its prey. Actually, it's not that unique because it's still used today by the anglerfish. And what they would do is they had a huge gape to their mouth, and they would throw that mouth open really quickly, and it would create a vacuum that would suck in their prey. Now, in order to do that, you have to have two things. One is a giant gape. The other thing is it has to be done very quickly. So, how did he do it? I'll show you how. There's that big head shield. See that bump on the back of that top shield? That bump has a muscle that attaches to it. And that muscle, when it contracts, there's a ball and socket joint right there. And when that muscle contracts, it takes the upper jaw and throws it up as it drops the lower jaw at the same time and creates that pressure, negative pressure, that sucks in its prey. You know what that muscle is? That muscle's trapezius. That's the same muscle that you have on your back. And once quadrupeds crawled up onto land, that muscle migrated from the skull back to the back, and it drug with it its nerve roots. That's why trapezius gets a cranial nerve instead of a back nerve. Now, you wouldn't have a clue about anything like that if you didn't have evolutionary theory to tell you. Look, ask these different questions. Although I will tell you, when I talk to medical students about this, they look at me and their first response is this going to be on the test? Okay. Some of you may have heard about this. This is Ardipithecus ramidus, since we're talking about human evolution. Only published in October, early October. Brand new species. And tells us an enormous amount about humans, which I'll get to in a little bit. But I only wish Darwin were here to see this. Because there's a reason that we go out into places like Africa and dig in the hot desert with the snakes and the scorpions and all these horrible things that might happen to you. Why do we do that? Because it's vacation? No. Because it's a way to find out about humans. Now, what did he have going when he tried to talk about human evolution? Well, through comparative anatomy, he looked around. Strangely, he did have one skull available to him and he saw it, which was a Neanderthal skull. But you know what? He looked at that Neanderthal skull, meaning Darwin looked at it, and he really didn't comment on it. And the reason he didn't comment is because it was too human. He couldn't hold that up and say this is a primitive animal, because it's not. Even he knew that, although we've been fighting about Neanderthals for the next 200 years. He knew humans have big brains. We've got that bundle of neurons sitting on our shoulder that is enormous. It's nearly 4 times bigger than the chimpanzee, which is the next most intelligent animal. So he knew we had that. He also knew we walk in a funny way. We're bipeds. Now, you woke up this morning and walked around and you didn't even think about it. No other mammal walks like we do. No other mammal has ever walked like we do, except our immediate ancestors. That's a weird way to get around, folks. Think of this. The fastest human on the planet Earth, a guy's named Bolt, in a 100-meter dash. He's a pretty fast guy. Can he catch a rabbit? No. Can he catch a house cat? No. Can he catch a little dog? No. He's fast? No, he's not fast. He's slow. But for us, he's fast. So that's a weird way to get around. And if you hurt a foot, we've all seen 3-legged dogs. They get along reasonably well. A 1-legged human isn't going to go very far. If you're out on the savannah, you're hyena food. It isn't going to help you. So there's that risk involved with standing up on 2 limbs too. And finally, technology. We are deeply indebted to technology, and it's embedded so far that we can't live without it. He knew that as well. He also said something. He said, if you want to understand humans and human evolution, go to Africa. Now, people didn't want to hear that. Africa is so primitive, you know. Humans couldn't possibly have come from Africa. In the American Museum, when they sent out, with Roy Chapman Andrews, they sent out those big expeditions to the Gobi Desert in Mongolia. They weren't looking for dinosaurs, folks. They were looking for humans, human fossils, because they thought they must be Asian. Well, they didn't find any human fossils. But luckily for them, they found a lot of dinosaurs. And they're still pulling dinosaurs out of that place. But that's not why they went originally. Darwin said go to Africa, and he was right. And you know why he said it? Because he looked at the 4 great apes. The orangutan, the chimp, the gorilla, and the human. And he looked at him and he said, you know what? That animal and that animal, the chimpanzee, are essentially identical. If I took a chimp and I shaved it, you could put that chimp on a table at the medical school, and those students could use their Gray's Anatomy and their Grant's dissectors and never know the difference. That's how close we are to these guys. Same muscles, same tendons, same bones, same organs. Now we can take comparative anatomy to a much finer resolution, which is DNA. Still comparative anatomy. And now we know it's absolutely true. We are very close to a chimp. And depending on what you read, we're somewhere around 98% identical to a chimp's DNA. 98%. In some cases, 99. Wow, that's close. That's closer than either one of us is to a gorilla. That's pretty darn close. But you can only take comparative anatomy so far. It tells us about the living animals. So these are your cousins, the common chimp and the bonobo, the pygmy chimp. Those are your cousins. But when you came in here, nobody knuckle walked. I don't think. I didn't see you knuckle walk. Nobody's got all that hair on your body. I don't think. Nobody has a brain that small. Nobody's got big canine teeth like that animal. So there are differences, significant differences. So how do we figure out how we got to where we are today? Can you do it in a molecular lab? No, you can't. There is only one way to do that. You've got to go get the fossils. And where do you go? Well, Darwin told us, go to Africa. And the place that we're going to be talking about is the Horn of Africa. That's the Red Sea, Gulf of Aden, and that's the Great African Rift. Now, why do we go there? Two reasons. One is the animals in question live there. That's important. If they didn't live there, you're not going to find their bones. Number two, the Arabian Peninsula is moving north. The Somali Peninsula is moving east, and it's creating a huge cleft, which we call the Great African Rift. And that, it creates huge exposures, a giant Grand Canyon, which means you can go in there and you can find the bones. If this geological process wasn't occurring, you'd never find them. That animal I just told you about, Dunkleosteus, that giant shark-like animal, a big fish. Well, has anyone ever found one? I haven't, and I've even looked. Well, the problem is you got to go to river cuts or road cuts and look for it because there aren't enough exposures to find them. So that's what this is. Imagine it a giant river cut or a giant road cut, which has enormous amounts of exposures. And a few years ago, in excess of 25 years ago, an animal was found on this spot. That's what it looks like today. It's a very, very dry desert. Hot. One of the hottest places on the planet. Well, the animal that was found there didn't live in this. It certainly didn't live in that kind of an environment. And I can tell you that because humans require enormous amounts of water. Well, there's not a lot of water there. Well, that animal, discovered from a team from the Cleveland Museum of Natural History, is the most famous fossil of all time, Lucy. There's Lucy, the most argued fossil of all time, the most studied fossil of all time. She's even taking a trip around the world now, visiting other countries. Now, why is she so important? Well, number one, she's 3.2 million years old. But that's not all. We've got other fossils that are older than that, but they're not this complete. In Lucy, we have a complete hip joint, a sacroiliac joint. We can mirror image a knee, a complete ankle joint. We've got elbows, we've got shoulders, we've got portions of a wrist, and we've got joints up and down the back. That's unheard of. That's fantastic because it allows you to do types of analyses that you otherwise couldn't. I told you she's 3.2 million years old in geological terms. How old is she in biological terms? Well, we can rough that out too. This is her lower jaw, her mandible. That's the first adult molar, second adult molar, third adult molar. So she's an adult. Incidentally, she's tiny. She's only about 3'2" tall. Tiny little thing. But she is a full adult because her third molars have erupted and all her bones are fused. But here's the key. Look at the first and second molar. You can see that the abrasive food she's been eating has worn through the very thick enamel on her teeth, and she has gigantic teeth, worn through the thick enamel into the dentin, the softer material under that. Look at the third molars. They're not even worn at all. Not even scratched. So she's an adult, but a young adult. So call her 20, something like that. The next big question is, how'd she walk? Because if she was on all fours, she's not a human ancestor. That's one of the defining characteristics of a human ancestor is how we walk. Well, fortunately for us, in order to walk upright, it requires all kinds of changes. In fact, every bone in your body, case can be made that it's been altered to allow you to walk upright. One of the big ones is the knee. There's the fossil, there's a human, there's a chimp. What's the difference? The difference is you and I are knock-kneed. Our knees are closer to each other than our hips are. Now I know you think, well, what's the big deal? That's a huge deal. Look at your dog or your cat when you go home. Their knees are actually further apart than their hips. We had to become knock-kneed to allow us to stand on one foot at a time, which is what bipedality is, 1 foot at a time. And incidentally, humans are the only mammals that can stand on 1 foot. Go home and tell your cat, yeah, you can beat me in a foot race, but stand on 1 foot. I want to see you do it. Look at that. See how it slants out to the side? See how that slants out to the side? Look at that, straight up. The shaft goes straight up to the hip. That's called a bicondylar angle or a valgus knee. That's a giveaway. You can always say determine if something's bipedal by looking at that. Now quickly, I'm just going to tell you, let's talk about some clinical medicine. Does that have any ramifications? Yes, it sure does. Women have broader hips than men. Why? Because our brains got too big and we couldn't get them through the birth canal. Do other mammals have pelvises that you can tell the difference between the sexes from across a room? No. That's unique to humans too. A chimpanzee, you can't tell if it's a male or female pelvis. A gorilla you can because the male's bigger, but anatomically it's the same. A horse pelvis is the same. Not in us. Female pelvises are so different. From across the room, I could tell you 99 out of 100 times which is female and which is male. Well, so women have these broader hips. That means they have a greater angle to their knee. That means that the big muscle in the front of your thigh, the quadricep muscle that attaches to your kneecap, pulls at a greater angle. That also means women dislocate their knees more often. Do you want to know why female athletes that are now becoming elite athletes are having so much trouble with their knees? Well, that's surely one of them, because of that greater angle that they have at the knee. Well, we're lucky in Lucy because we also have her pelvis. That's her sacrum, the bottom of your backbone. That's the sacroiliac joint, and that's the hip bone. Now, we can take that and we can mirror image it. Let me give you another clinical piece here. You see that joint right there? Sacroiliac joint. When someone says, my aching sacroiliac, that's what the joint they're talking about. Do you know what? In other animals, it doesn't ache. And you want to know why it doesn't ache? Because they fuse it. That's the ideal thing. You would want to fuse it. Humans can't fuse it. And the reason we can't fuse it is because you got to get that kid through the birth canal, and it's such a struggle that you literally have to keep that joint open and flexible to allow it to what they call nutate, to go back and forward as the fetus goes through the birth canal. Well, we can mirror image it, and there's Lucy, and there's a chimp. Boy, they don't look much alike at all. They really don't. Now remember, a pelvis is not just the locomotor organ, but it's an obstetric organ. I've been talking about that. And you know what's in your pelvis? Those of you that have had anatomy, there's a lot of stuff. I mean, you've got intestines, and you've got a bladder, you've got a prostate if you're male, you've got a uterus if you're female. There's a lot of stuff in there. And you just don't willy-nilly go moving it around. So it has to be a pretty good reason to go from something like that to something like this. And it was a good reason. Here's Lucy. There's a modern human. So why did you make all these changes? Well, I'm going to tell you one of my pet peeves in teaching anatomy. There's a group of muscles that attach here and run down to your thigh bone. And if those of you that have taken anatomy, and those of you that will, I'll tell you what you're going to do. Same thing I did. You're going to get 3x5 cards, and you're going to put the name of the muscle on the top of that 3x5 card, and then you're going to put its origin and its insertion, and then you're going to put down its innervation, and then you're going to put down its function, and you're going to memorize those suckers, one after another. And when you do that, any anatomy text you go to is going to tell you that the muscles that run over here, and I'll show you, these muscles, the gluteal muscles, in a human they'll say the anterior gluteals, minimus and medius, they're going to tell you what are they there for? Well, they're there to allow abduction, abduction of the thigh, this. It's in every anatomy text you'll read. I have to give them the A for that one. But it kills me. You know why it kills me? Because do you really think you went and changed your pelvis enormously and moved all those things around and changed your birth canal, on and on and on, so you could do this? Did anyone do this morning? Unless you have a peculiar dog-like habit, you probably didn't. That's not why we did it. The reason we did it is those muscles in a quadruped, when you pull on them, they force the limb back, they extend the thigh, and if your foot's on the ground, you gallop. That's the galloping complex. Works for everybody. Doesn't work for us. We took them and put them on the side of our hip. And now when they contract, when your foot's on the ground, they hold you up so you don't fall over on the unsupported side. And every step you take, you can feel these guys contracting. Very important complex. That's why Lucy made those changes. Not that she chose, but that's why natural selection selected those changes. They were advantageous to let you walk without waddling back and forth. Incidentally, he's not here, too bad, but that little guy over there is Dr. Scott Simpson. I'm sorry he's not here today. So what did Lucy tell us? Well, we walked away from Lucy with a couple of main big ideas. One, by 3.5 million years ago, our ancestors were walking essentially identically to us. If you were 100 yards away and you saw Lucy walk across a field, you would think it was a child. They had essentially completed the transition to bipedality. However, when you looked at her brain, the size of her head, you would realize this is not a modern human. And that decoupled the ideas. And I'm going to tell you, I kind of almost hate to do this on his birthday, but it's one of the rare things that Charles Darwin missed the boat on. But I don't fault him for this because he didn't have the information. The data was not available. Charles Darwin said, remember what I told you, the three things he noticed, the big brain, the tools, and the walking upright. Well, his idea was that the reason that they all came together, not a bad assumption, they all came together, and it went something like this. You had an intelligent chimpanzee-like animal. It started making tools. Got a genius chimp. Started knocking rocks together. And then you start a feedback loop. And the rocks get sharper, and they get more complex, and the brain gets bigger, and the tools are more complex, and the brain gets bigger, and pretty soon you got to stand up because you're carrying around all these dumb tools. How else are you going to carry them? You don't have pockets. So that was the idea. Well, we now know that's decoupled. That didn't work because we had been walking upright for at least, we now know, 2 million years before our brains started to expand. And we only see tools at 2.5 million. So we are first and foremost upright walkers. And this is my favorite site. This is the site of Laetoli, right on the edge of the Serengeti Plain in Tanzania. This is hard to imagine. It's 3.7 million years ago. 3 Lucy-like animals walked across the plain after a volcanic eruption. The volcano spewed all this ash out, created what's called a tuff. These animals walked across it. It ejected again and covered them, and they remained covered till Mary Leakey's team found them in the 70s. So they're footprints of our ancestors. There's a Lucy-sized one, left, right, left, right, left, right, left, right. And then a larger one following behind, and then a third individual stepping in that one's footprints, so they're superimposed. What a find. Do we see knuckle prints there? Nope. Do we see any handprints? No. What do we see? We see footprints that you would lose on a beach today. Look at that. There's the big toe, the lateral toes, there's the heel, and that is the arch. The arch to your foot is another unique human feature. No one else has arches to their feet. You know why we have arches to our feet? Because it's a shock absorber. It allows you to absorb shock because as a biped, you're putting all that energy on one leg at a time. And remember, conservation of energy, it just doesn't disappear. And you don't want to bang yourself up, particularly your joints, by squishing them. So you put an arch in your foot, and as you step on it, the arch flattens out, and the little muscles of your feet absorb the energy. That's one of the reasons that your feet sweat so much, because it transforms mechanical energy into heat. It's a great thing. But you know what? It's called eccentric contraction of the muscles, but that's not even important right now. I'm going to tell you that the Sumerians and the Babylonians and the Egyptians knew this. How can I say that? I can say that because if you had flat feet, they wouldn't let you march in the infantry. Because if you have flat feet, you will literally fracture the bones in your feet and your ankles, and then you're no good to anybody. It's called fatigue fractures. That's how important the arch is, and it's already there by 3.7 million. So there's Lucy walking upright. Back to Artie. And I start with this. That is Johannes Selassie. He's the curator of physical anthropology at the Cleveland Museum of Natural History. And I'm going to tell you, I wish you were here. He is the world's best fossil finder, fossil hominid finder. We can thank him for finding the Artie skeleton. He's the one that discovered it. I got to tell you, I was with him then. I was walking in the same place he was walking. I was looking at the ground the same way he was. But I wasn't the guy that said, oh, look at that. Here's a hominid. Like, oh, man, you know. So we can thank him for finding this specimen. Okay, what about Artie? Well, Artie changed things. Now, what I'm going to tell you is something that Darwin would have appreciated. And that is, don't triangulate in your mind from existing fossils, or worse yet, extant animals, back and try to average them to make what you think you will find as an ancestor. It won't work. And Artie sure tells us that. We had been carrying around, we meaning all of us that do human evolution fossil studies, paleoanthropology, a model in our head which was essentially a chimp. The chimp's primitive, right? And humans are advanced, right? Makes sense to me. Well, you can throw that one out the window. Deep six that idea, because Artie tells us that. So what does Artie tell us? Well, look at the skull. The skull was roadkill. It was in bad shape. It was crushed because it was in the clay, and the clays move. They move around a lot and break up the bones. Well, Gensua was able to take micro CT, scan the skull, and reconstruct it. Now, what does it tell us? A couple of really interesting things. It's a tiny skull. It has a brain the size of a chimp, no bigger, not even a smart chimp. What's more, it has little canines. If you go to the zoo and look at chimps, they have big tusky canines. And the reason they have those big tusky canines is the males fight other males for access to females. And they get in some nasty fights, and they use these canines as weapons. Well, in Artie, we have several other specimens of canines. In Artie, they don't have that shearing canine complex. They don't use, clearly their behavior had shifted, and they're not using their canines anymore to fight. How they walk. Well, I feel kind of guilty in here. We've got one of the experts on the pelvis sitting in the audience, Linda Spurlock. And she's here, and she helped reconstruct this. Again, you see how badly it's damaged. Well, they could go through and CT scan it, cut it into segments, and then Linda sat down and reconstructed what it would have looked like in life. And how many iterations did he go through? 11 iterations. Because everyone had to be okayed by everyone else on the team to make sure we weren't making some kind of a mistake. So how does it compare to Lucy? Lucy's in yellow, the gray one is Artie. You can see that Artie has already started to move those blades around. So she has a functioning complex for those muscles I told you about, the abductors. So she could stand on one foot. Not as well as Lucy, but she could do it. But there's something else here. See the bottom portion, how much longer that is than it is in Lucy? That's what you're sitting on right now. It's the ischium. And the big muscles in the back of your thigh, the hamstrings, attach onto that big tuberosity right here. You and I have a short little ischium because our hamstrings, we use them basically to decelerate your leg. I know that sounds peculiar, but when someone pulls a hamstring, it's normally when they're sprinting and they try to make a cut and they have to decelerate that limb and they fire the hamstring and tear it. That's when, so it's a decelerator. Not so in an ape and not so in Artie. It's the muscle that allows you to climb trees. That's the muscle that pushes you up a tree. So that implied that Artie is still up in the trees. Take a look at its hand. Its hand was a big shock. It's not knuckle walking. You know, the great apes walk on the back of their knuckles. It's a very peculiar way to get around. No one else has chosen that way to get around either, other than the African apes. Now, why do they do that? That's another lecture. But it's not here. So those ideas about our ancestors knuckle walking, throw them out the window. They did not knuckle walk. What's more, they have a very flexible wrist that allows them to put their palm down, which an ape cannot do. An African ape can't do that. They can put their palm down when they're climbing. So they're climbing a lot more like a monkey than they are like a great ape. Its foot. Oh, here's the big one. This is truly strange. You remember I showed you that Litoli footprint? This animal did not make that footprint. See how that big toe is standing out on the side? That is a grasping foot. All primates have grasping feet, save humans and our ancestors. We suddenly found an animal that I never would have imagined we'd find. We found an animal that is walking when it's on the ground on 2 feet, but it's not using its big toe. It's using that to climb, which tells you it has no arch, which we can then say that it wasn't walking very far when it came down and it wasn't running. Or if it ran short distances. So that was a big surprise. So just to show you, I don't have to tell you, didn't even really have to put those names up there, I hope. That Pan means chimpanzee and human. We brought our big toe into line to create the arch. Artie did not. Artie maintained an ape-like foot. So what did Artie tell us? Well, the bottom line is this. A lot of this skeleton is more like you and me than it is like a chimpanzee. Chimps have evolved enormously, much more than we would have imagined. Chimps are highly derived. They locomate in a peculiar form. They have different, because of that, they have different shoulders, different thoracic cages. They've changed their lower backs. They've done all kinds of things. They've elongated their arms. Artie is more like us. So a lot of the human condition is not highly derived. Much of it is, but some of it is not. Some of it is much more like Artie. Your hands, your elbows, your shoulders. Those are more like Artie than they are like a chimpanzee. One small step for a primate, one giant leap for mankind. So Artie was in the trees, but came down out of the trees and walked around on 2 feet. This is just quickly to show you the thing Artie tells us. That's the last common ancestor between chimps and humans, the yellow dot. Artie is here somewhere, so we're getting very close to the last common ancestor. Am I going to tell you what the last common ancestor looks like? Nope, I learned my lesson on Artie. Can't tell you. I'd love to tell you, but I can't. So stay tuned. Thank you, Charles Darwin. Now, I know this is long, but it's often and confidently been asserted that man's origin can never be known. Ignorance more frequently begets knowledge. It is those who know little, not those who know much, who so positively assert that this or that problem will never be solved by science. Charles Darwin. Does that hold true today, 150 years after the publication of Origin? Does it ever? This is one of my favorite examples. This is the plaque that went up on the Voyager spacecraft. And you know, NASA wanted to put a plaque on there, and they wanted it to be solid gold, but they ran out of money, so it was really only aluminum coated in gold. So if anybody finds it, they're going to think humans are awfully cheap. But more to the point, here's a pulsar, and if somebody finds it, they'll figure out the pulsar, and they can triangulate and find our solar system. There's the sun, there's the Earth, there goes Voyager, slingshotting around Jupiter. It's now further out in space than any machine we've ever made. You know the Voyager, if those of you that like Star Trek. Well, they put this on here hoping that they could see what we look like. Boy, is that a weird couple of animals. When they showed this to Congress, which they always have to do because NASA always has its hand out to Congress, they showed it to Congress, and what I'm going to tell you is true. I didn't make this one up. There was a senator, he's now dead unfortunately, a senator from the great state of North Carolina. His name was Jesse Helms. Now, Jesse Helms is a little on the conservative side. Kind of makes Sarah Palin look like a Bolshevik. Now, Jesse looked at this, and Jesse said, and I quote, "I will not be a party to the pandering of pornography in space." As though anybody that found this was going to say, there goes the neighborhood, the humans are here. So he caused so much trouble that they had to change it. And they changed it. So the female is no longer anatomically correct. I am serious about this. They changed truth. They changed human anatomy. So whoever finds it is going to say, look at this. Well, that looks like that would be a manipulatory organ. Yeah, we got that. That's a locomotor organ. Yeah, we got that. Now that thing, well, we're not sure about that thing, but where do you put it? Honest to God, Jesse had them change it, and they did it. Talk about vacuous kinds of thinking, but wait, it hasn't changed. God created humans pretty much in their present form at one time within the last 10,000 years or so. That's a Gallup poll in 2008. 44% of Americans said, yes, we agree. That's scary. There's another book being published this year. Yeah, another book by someone named Sarah Palin. And if you get a chance, thumb through it and see what she thinks of Darwin. Doesn't think very highly of the guy. So these things have not gone away. Next time you see Artie, it may be like this. Gosh, we can't have our children looking at science, can we? So you see, we haven't come very far from Jesse Helms. It's not the strongest of the species that survived, nor the most intelligent, but the one most responsive to change. Change. If I heard that word before, that's a good word. So I'll leave you with this. This is the HMS Bounty. That's the ship that Charles Darwin sailed around when he went to the Galapagos in South America. That's where he came up with so much of what ultimately became the center and the foundation of the origin of species. So, Beagle, what did I say? Oh, I'm sorry, Beagle, thank you. Thank you, wrong boat. That is the Bounty. No, excuse me, that is the Beagle. Thank you. So, I'll leave you with that and fare thee well, and happy birthday, Charles Darwin. Thanks. And thank you. Yeah, the Bounty had another problem. Mm-hmm. I'd be happy to. Not sure I can answer them, but I'd be happy to take them. Oh, no, Brian Redmond.
Given that divergent big toe and Artie, it seems like it's really conspicuous. I mean, it's really divergent. Do you have any idea, how well it could have walked, and then how often it actually would have walked upright compared to like Lucy?
Do you know, the question is looking at Artie's foot, it does have that highly divergent big toe, and it surely does. And can we reconstruct how it walked? Now, how do we know it was walking on 2 feet? Well, we know because the other toes, the lateral 4 toes, the heads of those toes, are what's called the metatarsals, are adapted. First of all, they're gigantic, they're huge. And they're adapted to allow it to go into hyperextension, which is what you do when you push off on your toes. And they're so huge that what it was doing, it was walking on the 4 lateral digits, not using the thumb digit, the big toe digit. So what that tells us is that it would have been an ungainly kind of a gait, and it certainly was not running, or not running any distances. And it certainly was not even walking distances because it didn't have an arch to absorb that energy. Now this is, you know what we can now take? One of the things Artie has told us, some of you in here probably believe that the reason humans stood upright was to allow us to run. And this is a very popular idea right now, and that we can run down animals until those poor animals fall on the ground and say, please kill me and eat me because I'm too tired to run anymore. That's ludicrous. And no one's ever done it that I'm aware of. You know, great runners don't go out and do it because animals don't like to be eaten. So they have all kinds of strategies not to be eaten. But anyway, this tells us, no, that had nothing to do with it, because this is an ungainly kind of a foot, and it wouldn't have allowed it to go any distances. When you get to a loosey kind of foot, at that point it's like a modern human. But the selective advantage of walking upright had nothing to do with the savanna theory, because Artie is in the forest, it's in a woodland. It had nothing to do with that. It had nothing to do with looking over tall grass and picking fruit out of trees. Whatever it was had to be strongly selected for to allow this animal to come down, and yet it still had to sleep in the trees probably.
What are they looking at for that selective force?
That's the big question. And the question is, ultimately, why would an animal a mammal stand on 2 feet? And, you know, there are more hypotheses about that than there are people in this room. None of them very good except one. I will preface it by saying whatever it was had to be enormously important to the individual animals. It had to be directly linked to their reproductive fitness, which is a biological way of saying it had to help them have babies. Bottom line. Because it sure slowed you down, and it sure meant you couldn't climb trees very well after you did it. And there's all kinds of reasons not to do it. Well, the reason is probably this, and this isn't my idea. Gee, I wish it was, but it's not. It's Owen Lovejoy's idea from Kent. And the idea is basically this. Why stand up? Well, the only reason I can think of is to carry something. Why? Well, otherwise, why do it? There's no reason to do it. So you stood up to carry something. What's the most important thing you can carry?
Your baby.
Your babies, your genes, those little bundles of your genes. That's important. That's the most important thing you can carry. The other important thing is to carry food, calories for the baby and the mother. We know that during the Miocene, call it 16 up to 12 million years ago, there were 200 species of great apes. They're all extinct now. They're all gone, except the 4 I showed you, the orang, the chimp, the gorilla, and the human. We're the only ones that are doing well. We've overpopulated the globe, folks. There's 6 billion of us. Now, how do we do that? How do we get out of that extinction event? The extinction event is this. If your environment decays due to who knows what, new predators, new toxins in the plants, who knows what, you've got people moving in, invaders. If you decay and you start losing offspring, if you don't balance it back out by having more offspring, you go extinct. Just that simple. Well, humans became very, very good at having offspring. And how do you do it? Well, you need more energy. You got to pump more energy into the system so the female can have more babies. She's got to be able to nurse. She has to be able to conceive again, on and on and on. Well, there's only one guy that's got a stake in it. Just one. He's got a genetic stake in this one, and that's the dad. So you switch from a polygynous system in the chimpanzee-like system where the males don't care about the offspring and they don't care about the females other than having sex. Well, we have a pair-bonded system where males and females will stay together to help raise the infant. That's an unusual thing for primates. We did it, and how can a male primate possibly carry enough calories back if he's on all fours? Can't do it. So standing up was the male's way to contribute to provisioning, giving food, and wolves, and there are social carnivores that do the same thing. And then the female has more calories. She can conceive again. You can increase your reproductive output. And then as soon as the female's got 2 dependent offspring, she has to stand up too, because you can't take care of them on all fours. So you're pushing it on both ends of the equation. So the important thing here is that the real adaptation, the Darwinian adaptation, was not upright walking. The adaptation was a shift in reproductive strategy to a pair-bonded system, and the only way that the male could contribute was by standing up. And that's why we stood up. And there we are today, still doing it. Now I'm just going to give you, there's a lot of examples, but I'm going to give you just one example here. Why is it in any culture in the world, any culture, if a female cheats on her pair bond, it doesn't go well. Some places they brand her, some places they burn her, some places they drown her, some places they just make her put a big red A on her chest. It just goes on and on. But if a male cheats on his pair bond, what's the big deal? Well, can you tell me why it's so different? That doesn't make any sense. But it does. Biologically, it does. Again, you can thank Darwin. The reason is because in a pair-bonded situation, I never know if my mate if the offspring is carrying my genes. I don't know. And if I've been cuckolded and I end up spending 16 years of bringing back food and protecting these people and doing all that stuff, and those aren't my genes, I have lost the evolutionary battle. And that's why it is such a big deal. It's mate guarding. Males are in pair-bonded situations are phenomenally good at guarding their mates so they don't get cuckolded. It sure happens though. It happens a lot. A good friend of mine was doing a study in Israel on a kibbutz, and they were doing blood typing, some blood study, and they couldn't publish because it turned out that 40% of the kids were not from the parent, the father they thought so. So I just want to throw that out as a little aside, that yeah, mate guarding works, but not all the time. Any other questions? Oh, come on. Don't ask me about birds. I'm not going to birds. We have a bird expert in the audience. All right, well, okay.
In your picture where you represented the surface anatomy of Ari, was it? Mm-hmm. He was drawn as, actually, was it he? You never specified, or was that a female?
It's a female.
She was drawn as very chimpanzee-like. Do you know if that is still considered correct or not? Because I know Neanderthals were originally depicted that way as well.
There's actually, if you look closely, she's not chimpanzee-like. If you look at the lengths of the bones and that sort of thing, but the hair, we have no way of knowing. Absolutely no way of knowing. That's a guess. Facial structure we're pretty good about because we have the skull. But there are little things like whites of the eyes. In other, this is something we don't think about much. In other primates, in other mammals, you don't see the whites of their eyes. In humans, you do. So we have no clue. That's soft tissue. We have no idea when that occurred. Probably it's a way to have communication. But I think Artie does show whites of her eyes. But that was just the guy that reconstructed her, J. maternus. It's a guess. It's a well-educated guess. All right, well, thank you very much.